Because I imagine students, so you said students hand in work beforehand, but are there further questions that they might have to, or further problems they would have to solve in the supervision itself?
So it sort of depends what the format is. So, for example, it may be that a particular question everyone in the group has solved, but they may not have understood that in doing the solution, they've actually made a particular assumption. And we might, for example, talk about that assumption. It's not that they've done something that's incorrect, but it's just a deeper exploration. Or it might have been a simple version where you might then think of, well, what if we make this problem slightly more complicated? How would we approach that? So again, that's thinking about extending the understanding. Or we might say, well, okay, you did that one. Now, what about this one? How would you approach that? And again, that's about testing whether you've got the understanding there, whether you've really understood the techniques and the ideas so that you can bring them to bear in an unfamiliar situation. Because that's the key skill. The key skill is to know, you need to know stuff, you need to understand, you need to have knowledge and facts and ideas in your head, and then you need to be able to synthesize them into an unfamiliar situation. And that's, for example, exactly what research is. Everything is unfamiliar. You have to bring to bear what you know on the unfamiliar.
Hello everyone, welcome to Cambridge from the Inside. We're here with a new guest today. Would you like to introduce yourself?
Yes, my name is James Keeler. I'm from the chemistry department here in Cambridge. I'm presently the head of department. I've been here quite a long while and always been actively involved in both teaching chemistry and also in the past in admissions in natural sciences.
Nice, amazing. Thank you, James, for giving us your time to be with us today. And today we're going to be talking about studying chemistry at Cambridge, the natural sciences course, and everything you need to know if you're thinking about studying Cambridge for university. So James, if someone wants to study chemistry at Cambridge, how do they go about that?
So the slightly strange answer is you can't. You can come here and study natural sciences. And in the natural sciences course, chemistry is part of that. So shall I explain a little bit about how that works? So in the natural sciences course, you basically have to do a range of science in the first year, also a range in the second year as well. And then in the third year and then in the fourth year, which is optional, you specialize in a single subject. So if you want to come here to do physics, ultimately, or chemistry, ultimately, or material science, or earth sciences, or biological subjects, you always come in through the natural sciences route and then build up a specialization over the course of your 3 or 4 years.
Nice. So just to make it clear for anyone who's listening and is a bit unsure of what they'll be studying if they choose natural sciences, can you describe what modules they might be doing each year?
Yes. So in the first year, everyone has to do 3 experimental subjects, plus a course in mathematics. And one of those experimental subjects is chemistry. So that would actually represent just 1/4 of the year. And then alongside that, you've got to do 2 further experimental subjects. And people who end up doing chemistry at the end of the third or the fourth year typically do subjects like physics or material science or earth sciences or some version of biology which is particularly molecular. Those are the common combinations. I think the most common combination for first year natural scientists on the physical science side is chemistry, physics, and material science alongside their mathematics. Now, of course, many people will have studied physics and chemistry at school or college before they come. But for example, very few people will have studied material science or earth sciences. And so these subjects are taught from scratch. And that's actually one of the advantages of them. It's an opportunity to learn some new science in the first year without having to have studied it before. So assuming that that's all, your interest in chemistry is maintained through the first year, When you get to the second year, you have to do 3 experimental subjects. But there's a lot more to choose from now. And if you're on the chemistry tack, there are 2 chemistries, which are very enterprisingly called Chemistry A and Chemistry B. And Chemistry A is mainly physical and theoretical chemistry. That's chemistry with models and numbers.
Yeah.
And Chemistry B is organic, inorganic, and a certain amount of biological chemistry. So together they cover the whole range of chemistry. And then in the third year, and optionally in the fourth year, you can do 100% chemistry. So that's typically how people do it. If they're heading towards chemistry, they do this sequence of subjects. Of course, on the way, the whole advantage of natural sciences is that people may decide actually they want to do physics, or they want to do earth sciences, or they want to do more biology. And those switches are completely seamless within the natural sciences, and they're open to everybody as you go through.
Nice. Thank you for explaining that. So am I right in thinking if they might think they're really interested in chemistry, they choose chemistry as one of their options in the first year, does the natural sciences course enable them to make a slight pivot to something like biochemistry or material science and then focus on one of those 2 options at the end of the degree?
Yes, absolutely. And in fact, in a sense, that's exactly what the course is designed to do. I mean, I think earth sciences is a very good example. It's not a subject that many people have learned, have studied at school or college. It's very, very topical. It's very up to date and modern. It covers a very wide range from the fossil record, from paleontology through rocks, how the Earth was formed, how life occurred on Earth, and so on. And I know from years of experience here that quite a lot of people will take that as their third subject in the first year, and then they will discover that's the thing they wanted to do that they'd really not heard of before, and they will specialize in that area. Other people will take that subject in the first year alongside, say, their chemistry or physics and say, well, that was all very interesting, but I'm actually going to carry on with the subject I intended to. And all of these options are really absolutely seamless within natural sciences. You can move from one to the other very straightforwardly, and it's positively encouraged.
Nice. Can you share with us, for any of the viewers who don't know, what kind of chemistry there is in earth sciences?
That might be quite difficult.
Or the overlaps between what kind of
I see what you
skills
mean.
and
Sorry, yes.
yeah.
So I think material science perhaps works a bit better than earth sciences. So again, material science is something people haven't studied before coming here. So material science, again, it's a relatively young science compared to chemistry and physics. But what they're doing is looking at the materials of our world. That means things like alloys, means things like plastics, means things like soft materials like you might find in connective tissues in living matter, and trying to understand all of the special properties of these materials from the point of view of a physical scientist. So thinking about them in terms of their molecular structure, thinking about the interactions involved, thinking about how you measure them and exploit them and so on. And this is essentially a synthesis of chemistry and physics. You need all the techniques, all of the understanding that these traditional subjects have, but brought to bear on this relatively new area of material science. So, for example, if you studied material science in the second year, there's a lot of overlap between that and some things that we do in inorganic chemistry, looking at crystal structures and so on. Also with physical chemistry, looking at semiconductors and how they work and so on. And again, those kinds of topics also occur in physics. So they're all seen in slightly different ways, but you would have a real enrichment of your understanding of solid materials in chemistry from having studied material science. And I think the same would be true for physics as well.
Nice. Another thing I wanted to ask is a lot of people watching this would be taking chemistry A level, and they would probably think chemistry as a kind of singular science. But I heard you using terms like inorganic chemistry and physical chemistry and organic chemistry. Can you explain what those 3 terms mean?
Sure, that's right. So, I mean, chemistry is typically and sort of historically been divided into these three groups. So, physical chemistry would mean particularly looking at physical models of bonding and structure and things like that. The application of quantum mechanics to that, particularly spectroscopy as well. So, how do you probe and understand the properties of molecules? Organic chemistry typically has been about how do you make molecules. Here's a molecule, how do I make it? Using a series of chemical steps, so particularly synthesis. And inorganic chemistry is really trying to look at sort of the rest of the periodic table and the incredible variety of chemical structures you get from things like transition metal compounds, things like ceramics, things like semiconductor materials and so on, a huge range of things. And these are sort of the traditional divisions of the subject. But as with all traditional divisions, they really have failed in modern science because, for example, people who do organic chemistry traditionally might these days use theoretical calculations to think about how to go about synthesizing molecules and what reactions to use. Again, I mentioned materials chemistry. If you're interested in solid materials and you're interested in making a material, for example, for the solid electrolyte in a battery, again, you might need some theory. You might need physical techniques that you might study in physical chemistry. And you might also need some characterization, some spectroscopic techniques. And then there's the whole domain of chemical biology or biological chemistry, which is looking at biological processes from a molecular point of view. And that's a whole nother area. So in modern chemistry, all of these areas have got completely muddled up. They've drawn in things from other areas. So although particularly some of the first year teaching is still sort of subdivided in this traditional way, particularly as you get towards the end of the course, you find that these kinds of divisions don't really mean anything anymore.
Interesting. That's really interesting. So in the first year, there's several modules, and one of them is chemistry. And then in the second year, there's chemistry A and chemistry B. But I noticed that there's inorganic, organic, and physical. Yeah. How do they fit into chemistry A and chemistry B?
So chemistry A is mostly physical chemistry and theoretical chemistry. And it basically starts out by taking a look at quantum mechanics, which is the theory you need to describe small systems like molecules, and then using that theory to help you understand chemical bonding, the spectroscopy of atoms and molecules, how you then understand the bulk properties, things you can actually measure physically from materials, and then also about the properties of solids and so on. So it's based on this kind of building models of the chemical world. Chemistry B really has got three strands in it. It's looking at this organic chemistry, so reactions, particularly from the mechanistic point of view. How do we understand these reactions, why they behave in the way they do, and then how you can put these reactions together to make synthesize molecules. The inorganic chemistry has got a very big topic. They've got to try and understand this vast range of chemistry that you get in the periodic table. And to help with that, they start out focusing on the non-metals and all the kind of special compounds you get by bonding non-metals together. And just that in itself is very complicated. And then looking at transition metal complexes and the kind of the complexity and the richness you can get there, and particularly how also if you combine transition metals with organic materials. And then the third strand is looking at biological chemistry. So this is looking at biological molecules with a chemist's eye and saying, why do these molecules have the structure and function they do? How can we understand their role in biology through our understanding of chemistry? So that's basically how those two things divide up.
Nice. And say a natural sciences student chooses one of chemistry A or one of the two chemistry options. Can they subsequently choose chemistry as their third year module, or do they need to take both chemistry A and chemistry B?
So to get the best coverage of chemistry, if you're planning on doing chemistry in the 3rd and 4th year, then it is best to do chemistry A and chemistry B. But in the spirit of natural sciences, we recognize that isn't always what people want to do. And it may be they have other interests they want to pursue. So we actually have a special route for people that have only done chemistry B. They can rejoin chemistry in the 3rd year. They do a sort of a supplementary catch-up in physical and theoretical chemistry, not the whole course, but some key ideas, and then they carry on. If people have only done chemistry A, again, they can rejoin in the 3rd year. Typically what they do there is a bit of study over the preceding holiday, just to catch up with a few key ideas. And that seems to work out pretty well. We have, of the class, probably 15 to 20% actually take that route. And there are lots of options in the 3rd year chemistry. So they've then got options they can choose which fit with what they've done before in the 2nd year. And people will do very well at the end of the year, regardless of the route they've come in.
Nice.
So it's a little bit of extra work, I would say, but it's not. It's something that people find perfectly doable.
So it sounds like in the natural sciences course, there's a lot of open doors, and doors aren't shut if you change your mind.
Up to a point. I mean, if you don't do chemistry in the 1st year, that really is the end of it. You can't switch in the 2nd year. And I think the same is true in subjects like physics. But we try and keep as many of the doors open as we possibly can.
Nice. And I think you mentioned that there's a potential 4th year for students who take chemistry in the 3rd year. What's the difference between the 3rd and the 4th year?
So, as in most universities, you can do a bachelor's degree in the 3 years, and you can leave after the 3 years. In Cambridge, you would leave with a BA. Most places, you would leave with a BSc. If you want to, you can stay on and do the 4th year, which is called an integrated master's. And if you do that, you would get an MSci degree, which in other universities would be an MChem degree. And the difference really is that in the 4th year, there's a strong emphasis on a research project. So in chemistry, there's a 16-week research project to do, and that forms 35% of the marks, for example, in the final year. So that's a very important part of the course. And you do lectures alongside those, but these lectures are very much more focused on the research activity in the department. So in a sense, you might think in the 1st, 2nd, and to an extent in the 3rd year, you've been learning the ground, laying the basis of the subject. In the 4th year, you get to try and grapple with what modern topics in chemistry are, what people are actually doing in the research laboratories. So that people often find the 4th year quite different, very exciting, because A, you're doing your research project, which is a new piece of work. And secondly, you're looking at work which is very, very close to where the research frontier is. So it's somewhat the same, more study, more exams, but with a bit of a different focus, I would say.
Nice. And in these research projects, do students join a research group that exists in Cambridge?
Yes. So in the research project, you join a research group as a junior researcher. And typically you would be given an initial project to work on by the professor or the lecturer who's leading that group. And then typically you're assigned a more senior PhD student or postdoctoral worker who will oversee your work on a day-to-day basis. And the idea is once you get going, you should be reasonably independent in that, using the skills that you've already learned. But of course, research is very difficult. It's quite unpredictable. So it's a very different experience to doing laboratory work of a set laboratory work, practicals and so on.
Nice. So I imagine if someone could see themselves maybe doing a PhD, but they're not too sure, this 4th year is a perfect opportunity to see what it's like without fully committing.
Yes, I think, most places will, if you're going to start a PhD, they will have expected you to study to master's level. So that either means having done one of these 4-year undergraduate courses, which is an integrated master's, or to have done a 1-year master's course as a standalone. I mean, if you like the place, it's easy just to carry on with the fourth year. It will give you the necessary skills, and it will put you in a place to apply for PhDs if that's what you want to do.
Nice. So moving on to the teaching for the course, how are natural science students and students taking the chemistry options, how are they taught in the course?
So it's pretty much the same pattern in all of the subjects. You have 3 strands of learning. So you have the lectures, you have your small group teaching, tutorial style teaching, which confusingly in Cambridge is called supervision for some reason, and then some practical component. So in the lectures, this is basically someone laying out the content of the course with, in other words, what you should know and how you should know it. And this is really how the course content is defined in Cambridge for all the subjects. These lectures are often to quite large classes, particularly in the first year. So first year chemistry lecture is about 500. So it's quite a different experience to learning in a small class. Typically as well in the lectures, you're given a handout, so quite a lot of pre-prepared material. Sometimes it's almost completely like chapters from a book. And almost all the lectures are also recorded these days, so you can review them afterwards. So that's the lectures, and they're quite densely packed actually. Then there's the tutorial style teaching, the supervisions, and typically what happens in these is that you, for each subject you're doing, for each week during the term, you will have a 1-hour supervision. And you will have prepared some work in advance for that. So in physical science subjects, that's typically problems, and these problems parallel what's going on in the lecture courses. In biological subjects and things like earth sciences, they're more likely to want very carefully structured essays or short answers. And you go along, you've handed your work in advance, and that's been marked by the person that's supervising you. And then there's a discussion, and what that discussion will be depends on what you need. Often it will be focused on correcting the problems which you perhaps haven't done perfectly, or exploring other options, or talking about other ways of thinking about the topic. And of course, it's your chance to ask questions and ask for clarification. So it's a very close personalized teaching, usually done in a group of 2 or 4 students. And then you've got the practicals. Again, these vary from subject to subject, but typically you might spend an afternoon doing some practical activity. So in chemistry, for example, you would be learning chemical techniques of separation and different ways you do reactions, how you record spectra and so on, and then whatever that means for the other subjects. And this is the pattern of work basically throughout the years. And the only time when that really changes is when you get to the 4th year, when instead of doing your practical work as a class, the practical work is, of course, the project we've already talked about.
Nice. And what kind of thing, say if, I don't know, it's a hypothetical situation, but you had the natural sciences course, but there weren't any supervisions, what kind of things do you think the students would miss out on?
So I think the thing that you would miss out on the supervisions is, it's one thing to read about something, and it's one thing to read, to hear someone lecture it, but it's entirely another thing to do it. And particularly to do it when you're trying to apply the knowledge which you have gathered from the lectures or from a book to a novel situation. And that is the thing, it's developing that skill to take what you have learned and apply it. That's the thing that's the difficult part. And I think that's where the supervisions come into their own, because you are asked to apply it, and then you have an opportunity to explore whether you've applied it correctly, or whether you could have done it another way, or whether there are alternatives and so on. And it's not exactly repetition, but it's the experience of the subject guided very closely by someone who knows the subject well. That's the crucial thing that you would miss, I think. And I think there's nothing like actually having to do it or explain yourself to clarify whether or not you really understand what's going on.
Because I imagine students, so you said students hand in work beforehand, but are there further questions that they might have to, or further problems they would have to solve in the supervision itself?
So it sort of depends what the format is. So, for example, it may be that a particular question everyone in the group has solved, but they may not have understood that in doing the solution, they have actually made a particular assumption. And we might, if, for example, talk about that assumption. It's not that they've done something that's incorrect, but it's just a deeper exploration. Or it might have been a simple version where you might then think of, well, what if we make this problem slightly more complicated? How would we approach that? So again, that's thinking about extending the understanding. Or we might say, well, okay, you did that one. Now, what about this one? How would you approach that? And again, that's about testing whether you've got the understanding there, whether you've really understood the techniques and the ideas so that you can bring them to bear in an unfamiliar situation. Because that's the key skill. The key skill is to know, you need to know stuff, you need to understand, you need to have knowledge and facts and ideas in your head, and then you need to be able to synthesize them into an unfamiliar situation. And that's, for example, exactly what research is. Everything is unfamiliar. You have to bring to bear what you know on the unfamiliar.
Nice. Sounds really cool. And in the chemistry strand within natural sciences, who's teaching the supervisions? Is it the same chemistry academic for each college, or are there multiple types of studies?
So this is pretty variable, but I would say typically for first years, a lot of the teaching, a lot of the supervision is done by PhD students or postdoctoral workers, many of whom have been through the course themselves, but not that many years ago. So we find these people are often very, very enthusiastic teachers because, first of all, they're close to the subject material. They often feel it's very important for them to, if you like, give back the knowledge that they were taught when they were undergraduates. And I think they bring an energy and an enthusiasm. Now, when you get to the more advanced parts of the course, that's where a little more experience for someone a little bit older and grayer might come into play. And you tend to find that the more senior people, like the professors and the lecturers, will probably do more of their teaching in the more advanced parts of the course, where perhaps that experience counts for a little bit more, even though they don't have the freshness necessarily that you would get from the PhD students. And you're not, on the whole, taught by the same person over and over again. As you change from one big block, say a big topic to another topic, you might get another supervisor. So it's not like you're changing every week, but it's not like you'll be stuck with the same person for years and years and years. So there's you'll have a variety of people teaching you. They will take a variety of approaches. You may not like some of their approaches, but again, it's very useful to learn in different ways, and different people have different ways of trying to teach you.
So am I right in thinking certain academics would teach certain lecture courses? Is that how that works?
Yes, I mean, typically people have an area where they're comfortable to teach. So I would be comfortable teaching some physical chemistry and some bits of theoretical chemistry. I would not be comfortable to teaching biological or organic chemistry. It's a long while ago when I studied it, and it's not something I've kept up. So I wouldn't attempt to do that. So people tend to go for the things that they feel comfortable with. And particularly for more advanced work, of course, they tend to focus on areas which are reasonably close to their research area as well.
Nice. Another question that we have is I think there's a lot of misconceptions about natural sciences, and a lot of people think that if they were to choose natural sciences, that by the end of their course, they would know less chemistry than someone who's chosen a straight chemistry course. Is that the case?
So I would say if you do chemistry through the natural sciences here, it is, I suppose, possible that there'll be some bits of chemistry that someone that's done a straight chemistry course will have done, which we won't have covered here. I think I can be absolutely confident that we've covered all of the basics, all of the key ideas very, very well. I'm sure about that. okay, there may not be quite as much in some other areas, but I think there's a big compensation, and that is that our students have studied material science, physics, earth sciences, biochemistry, and they bring that expertise and that knowledge and that broader form of thinking to their study of chemistry. And I think that more than compensates for perhaps a small amount of missing pure chemistry. And I have to say this, sorry if it comes across as arrogant, but no one has ever complained that Cambridge chemists don't know enough.
No, and I don't think no one would expect, when you say it like that, no one would expect a Cambridge chemist to not be an expert in their field.
Yeah, that's right. Yes.
So the other question I had was, a lot of students also, because with how the system works, and in a given year, you can only choose between Oxford or Cambridge if you're thinking of applying to the universities. And in Oxford, they offer straight chemistry. Yeah. What advice do you have for someone who's deciding between natural sciences at Cambridge and chemistry at Oxford? Yeah.
So this, I should fess up at this point, I did chemistry at Oxford.
Oh, I didn't know that.
And so for me, it really was a straightforward choice. I mean, I knew that chemistry was the thing I really wanted to do. And I also knew, and I think it was probably true, that I would not have been very comfortable studying physics at university level. So it was a straightforward choice for me. I think actually it's more complicated these days, because I think it's much more likely that students will feel comfortable across a range of sciences than when I was at school. And then you really just got to think about what it is you want to do. You know, if you are convinced that chemistry is the thing you want to do, you might find that the natural sciences course is actually annoying because it won't let you get on with the study of chemistry. And in that case, I would say, go somewhere else and go for the Oxford option. If you are still hovering and not sure whether it's chemistry or physics that you want to do, or biology, and if you are attracted by the possibility of studying these other subjects that we offer here, like earth sciences and materials and so on, then natural sciences might really be a good choice for you. And in my experience over many years teaching here is that people find a route through natural sciences which they are really very happy with. It's very uncommon for you to meet people who say, I really couldn't do what I wanted to do. In fact, people usually say, I did something which I never imagined I could do. Right? That's a more common response. Now, I don't want to make it sound like natural sciences is a subject for people who can't make up their minds, because ultimately you do have to make up your minds about what you're going to specialise in. Yeah. It's just that your approach to making that decision is a little bit different than if you plump straight at the beginning.
Nice. And with the different choices and options you can make in the natural sciences course, am I right in thinking that not many chemistry courses, at least compared to the Oxford chemistry course, enables you to kind of carve your way and have the freedom to choose different options like you do in the natural sciences course?
I think natural sciences offers you a lot more options. I think it's very common in other chemistry courses to offer supplementary subjects or additional subjects you might do alongside chemistry. I think the difference is for natural sciences, if you do physics in the first year, that's not physics for chemists. That's not some sort of diluted version of physics. It is the physics course that's the same for everybody. If you do the biological courses, if you did one of those in the first year, that's not biology for chemistry, that is the biology course. And I think that gives the whole thing a different feeling, because the lecturer is lecturing to you as if you are fully committed in that subject, rather than saying, oh, well, these are people who aren't really interested in my subject. They're just doing a supplementary in physics or whatever. So I think it feels different. And I think that's something that's worth thinking about.
Nice. Yeah, I think I'd quickly say that I also studied chemistry at Oxford and looking at the natural sciences course and I think what one kind of key difference it seems is, as you were saying, in the natural sciences course, someone will feel like they have a lot of options and they could choose, and they will eventually have to make a firm choice, but they can choose. Whereas once you've chosen to do a straight chemistry course at Oxford, there's not much there's not much flexibility besides a set of optional modules at your third year and being able to choose your fourth year project, and I think students should decide which path they would like to undergo.
Yeah. But I think it's very much a personal choice. It's how you feel about the subject.
Yeah. And the next thing that we have is so what would you say, from what you've seen, students going through the natural sciences course, what either benefit or what perks or benefits or ways chemists have used the system to mould their path? What benefits are there to doing the natural sciences course for chemists?
So I think as I've sort of mentioned before, you have you bring to your chemistry an understanding of other subjects. And they can be different subjects, different for everyone really, depending on the courses they've done. And I think this knowledge of other areas of science is very reinforcing ultimately your chemistry. And so, for example, if you finished a chemistry course and you stayed in our department here to do a PhD, you might end up doing a course of, say, working in a group that works on materials chemistry, so new materials for batteries or new materials for catalysts or new materials for solar cells. All these things are done in chemistry. And if you'd studied materials chemistry, if you'd studied the materials course, you would have an extra understanding of that you've not got from the chemistry course. If you'd studied physics, you would have an extra understanding there, some of the processes which you wouldn't have got from chemistry. So that other knowledge which you've gained from other areas is really beneficial. And I think even if you just take it beyond particular facts, the fact that you've heard other scientists talking about things in slightly different language, that in itself is also very useful, because it's very easy if you get stuck in a chemistry department, so to speak, to only think of things in that chemistry framework. If you've had to step outside that and see how other people talk about similar things, but in different language, but actually ultimately talking about the same kinds of processes, that just gives you a broader understanding. I think it's incredibly beneficial.
Nice. So am I right in thinking, say you have a first year natural sciences student and they think they really like quantum mechanics and they're choosing the chemistry option and the physics option, do they always have does the natural sciences course enable them to decide whether they want to approach quantum mechanics from a physical chemist point of view or narrow down into the physics pathway?
So I think if you're doing second year physics and they're teaching you quantum mechanics, then you have to, as it were, learn it and express it in the way they want you to. And that will be different from the way that the second year chemists learn about quantum mechanics, because the two subjects have different agenda about the sorts of things we think are most important. So you kind of learn them separately, but where you gain is, of course, they are fundamentally the same thing. And lots of students will say that hearing about something in one subject has helped them understand the other one, and vice versa. And seeing them as a whole, again, is very positive. Now, of course, when you get to the third year, say, if you're going to do more advanced quantum mechanics, then probably that's going to diverge a lot more between subjects like physics and chemistry, where the concerns at the advanced level are very different.
So this is a bit off topic, but would you say for research, does a natural sciences course give you good holistic skills that are advantageous for the world of research?
I think they do. I think it's absolutely the case. The divisions of science really come from the 19th century. And things have changed a lot since then.
Yeah.
if you look at the lecturers and professors in the chemistry department, which I know best, of course, I can talk about that. The truth is that many of them don't have chemistry degrees, right? And that's because they have approached chemical topics through starting in physics or starting in mathematics or starting in biochemistry. Ultimately, they've come in and they've come to rest very happily in the chemistry department, but that's not where they started.
Yeah.
And that's very much a reflection of how modern science goes. People tend to be grounded in a particular discipline, but after that, you can be anywhere you like, really.
Wow, that's really exciting. That sounds really cool. And lastly, this is a question for students who are thinking about which A levels to choose, and they're maybe thinking about studying science or chemistry at university. What A levels would you say give you good preparation for studying chemistry?
So chemistry, obviously, and we should say, of course, that means A level and anything that's equivalent to A level in terms of content and level. I think maths is pretty much essential. I think if you want to study chemistry, it is basically in large part a quantitative subject. So you've got to have some competence in mathematics. And then it kind of depends what you want to add to that. I mean, some people, obviously, a lot of people would add physics because that's talking about the microscopic systems and molecular systems to some extent. Other people might add biology to that, so looking at what's the molecular world from the point of view of biology. So depending on which sort of shade you're going, either physics or biology is fine. Maths is, I think, pretty much essential. And people who are interested in maths quite often do further maths as well, because that kind of facility with mathematics is crucial to a lot of physical sciences. Once you get outside those kind of core subjects, the direct relation to what you might do in chemistry is more tenuous, I would say.
Okay, nice, amazing. Well, I think that's everything that we have. Thank you, James, so much for your time. It's a really good podcast on chemistry. And thanks for the viewers for watching. We're hoping to do more podcasts on the remaining courses of the that we provide at the University of Cambridge. So stay tuned for that, and we'll see you guys next time.
Okay.
Thank you. Oh, how was that?
Oh, I haven't done one before, so I don't know.
I thought that was really, really good.